The title of talk is Advancing the latest GPCP product version 3.1 in high latitudes using recent observation from space. This is Ali Behrangi from University of Arizona, and I should acknowledge my colleagues Dr. George Hoppin, Bob Adler Yangsang, Dave Wolpin, Eric Nelkin, JJ Wang, and Dr. Ging. So GPCP is one of the few state-of-the-art global long-term precipitation products going back to 1979, well-maintained, and is used as an observational reference by international communities. In light of new estimates like those available from TRIM, GPM class at GRACE, it was recognized that GPCP update is needed. User require higher resolution. Currently, what we have, we had for GPCP 2.3 was monthly 2.5 degree and daily 1 degree, which is coarse. So the objective of the new product is to use the new instruments, satellites, as well as the higher resolution, spatial resolution for GPCP. Previous studies, like the one by Bob Adler, shows that GPCP is likely having a lot of uncertainties over ocean, especially over high latitude regions. Our study in 2012 provided a method to combine TRIM, which is strong in terms of capturing moderate and intense precipitation, with cloud-side, which is strong in capturing light rainfall, drizzle, and snowfall. And the merged product that was developed in our 2012 work was used in 2014 paper to compare it with the GPCP and identify some regions that might have differences with GPCP and added insight to us to some of the potential problems that GPCP might have. With the launch of GPM in 2014, we updated MCTA approach to MCTG, which is Merged Class at Trim GPM, and that was the latest version that provide us with insights about areas that probably requires development in GPCP. So that was the foundation for 3.1 version. There are many changes in the 3.1 compared to the previous version. I just highlighted a few here. The upgrading the geostationary IR, extending it from 40 degree to 60 degree north-south, and also using the newer version of passive microwave. Still is not very new, but it's GPROF 2010 instead of the older version. Consistency between airs and TOVs, and making sure that the merged product is consistent from 40 degree to 90 degree north and south. It is used, and it is adjusted by MCTG. The Persian CDR adjusted by GPROF is also adjusted by TCC, and tropical combined climatology within 25 degrees south and north. And TRIM combined climatology is a combination of radiometer, radar, as well as the combined radar and radiometer product that is now using GPM as well. The products available from GPCP 3.1 are listed here. The two variables that are new are gauge relative weight and quality index. Comparing the 3.1 with GPCP old version, you can see increase of precipitation along the storm tracks and tropics around 40 degrees south, and a little bit decrease in around 60 degrees south. Comparing the GPCP with the DPR, GPM DPR shows that significant increase in precipitation in high latitude exists, and that's expected because DPR can underestimate. There are some features that previously we were not comfortable with, like this gradient in the Atlantic Ocean, but now the gradient is more consistent with clouds, as you can see, as well as reanalysis. The distribution, zonal distribution, also shows that there are some changes in the GPCP, going up in around 40 degrees south and going down around 60 degrees south and going up around 40 degrees north. Overall, we have a slight decrease in land precipitation, global land precipitation, but have like about 6% increase over ocean, and overall 4.5% over land and ocean. The conclusions are, I'm not going to read it again because I just talked about it, but in future, analysis over land will be continued and will be a focus of our work. This will likely include changes in gauge under cache correction methods, partly based on the insights we gain from SUI measurements, gauge, and GRACE analysis. I should acknowledge the funding source. Thank you.